Can you see?
Yes.
Okay.
So I started the presentation. So hello. During our Thailand project, we had to work in a group on the manufacture of a product and everything relates to the production of this product, such as the different risk and hazard, or even the critical limit and corrective action. Our group stumbled upon making a Thai specialty, the Tom Yum soup. For a little over a month, we did video conference to discover a product and make a slideshow to explain the different things we learned during the project. So now we are going to make the presentation of a product.
Okay. So first, we will talk about our product. So as you know, our product is like a Tom Yum soup. So what is Tom Yum soup? This product is called a Tom Yum soup, which is the meaning of the Tom is boil and Yum is mixed. And we boil and mix together, and the packaging we're using a can. Okay, so what does it look like? So it is an orange color soup with mainly spicy, sour, and salty. Next, we move to talking about shelf life. So in our product, we put it in the packaging of using can. It will be around 2 years with room temperature. For the instance of, we use the word like best before. It's a low pH food and use a lot of herbs, so it has many benefits to our body. It has high in zinc. It can promote immunity, anti-inflammatory, and help stomach aches. And example of ingredients is the lemongrass on the left side, which can promote digestive systems, help stomach aches, and decrease flatulence. The second ingredient that I choose is the shrimp. It has high protein and potassium, which can help maintain your body. Okay, next is the diagram of the processing. Okay, so on the processing, first of all, we need we use all of our ingredients to clean it first. After we cleaning it, next we have to cut into the pieces because it will be easier and it has more flavor. Next, after we cutting off our ingredients, we blanching at the temperature of around 65 degrees Celsius at around 5 minutes. And then we use the mixing with seafood, tomato, fish sauce, shrimps, and mushroom, like mixing and blanching together. And then after that, we put it in cans. After we put it in cans, we have to steam it. And in the step of steaming, it should not be any leaking. After we steam it, pasteurization. So why do we use pasteurization instead of sterilization? Because Tom Yum soup is a low pH food, and we already branched it first, and low pH food, so it's hard for microbial to grow. So pasteurization is good. After finish pasteurization, we move to the labeling on the side around the can. After that, we can store it, and then we get the Tom Yum soups and ready to sell. Okay, next.
I'm going to present details of each step and determination of critical control points. First of all, step receiving the real material and cleaning. The other is microbiological and physical. Its meeting have a risk the presence, contamination, multiplication, and survival. We have to pay attention to the equipment, raw material, labor, method, and environment. The criticality is free. Measure to control, check the raw material at the reception and after cleaning. Train the staff to clean properly. At each step, there is no CCP. Next slide, please. We can also have step. The other is chemical, for example, pesticide, and its called have risk is presence, and the cause is real material. The criticality is free. Measure to control is check the real material at the reception, certificate of analysis, at the step CCP. The next step is cutting. The other is microbiological and physical. Of the risk is presence and contamination. It's due to equipment, raw material, labor, and method. The criticality is 2. The measure to control, disinfect before H2 and train the labor. At this step, there is no CCP.
The main goal for the step of blanching is to reduce the enzyme population. Is a pre-treatment. So for this step, what type of hazard? The hazard is microbiological. This hazard has the risk of survival of microorganisms. This risk could be due to the method, the equipment, the labor, or the environment. For example, the operator did not leave the food long enough, so the microorganism survived. We have classified this step at critical level 3 because if we have a problem overcome, the problem later in the process. To control this step, you have to control of water temperature and blanching time, as well as training of the labor. This step is not considered a CCP. Let's go to the mixing step. The main goal for the step of mixing is to mix all the ingredients together to obtain an homogeneous product. So for the mixing step, what type of hazard? The hazards are microbiological and physical. This hazard has the risk of presence of microorganisms, but also a risk of contamination of the product. This risk could be due to the equipment, but also due to the raw material. For example, the mixer is not clean, and when we immerse it in a product, it might be contaminated. We have classified this step at critical level 2 because this step presents a fairly substantial risk of contamination of the product. To control this step, you have to train the labor. This step is not considered a CCP. Let's go to the step of putting in can. The goal for the step of putting in can is put the product in can to sim after that. So what's the hazard of this step? The hazards are microbiological, but also physical. This hazard has the risk of presence of microorganisms, but also a risk of contamination of the product. This risk could be due to the equipment, but also of a method and of the labor. For example, the can were poorly cleaned, so the microorganisms are still present. We have classified this step at critical level 2 because this step presents a fairly substantial risk of contamination of the product. To control this step, you have to train the labor. This step is not considered a CCP. Let's go to the step of simming.
I'm going to present simming step. The goal of the step is the airtight the box. The hazard, basically, is a microbiological and chemical. There are two kinds of risk. The first risk is multiplication due to duration of the step. And the second step, second risk, is a contamination due to improper method. You can see critical level is number 1 because this step is very important. Why is it so important? Because if the box is not airtight, it might recontamination after the pasteurization. That's why the step is a critical control point. Next slide, please. After simming step, we're going to look closer the pasteurization step. The goal on this step is to destroy microorganisms. So the risk is survival of this microorganism. That's why the critical level is number 1 and very important. If there is a problem, is probably caused by improper method. What are the measures? The measure is to control, to check the temperature and the time. The pasteurization step is the second CCP of the process. Let's go to storing. The last step of the process is storing step. What is the CCP? Storing step is not a CCP. In this step, there is no risk and no hazard because the product and are sterilized and protect. At last, to guarantee this previous step must be correctly carried out. And let's go to the critical limit plan of the monitoring and corrective action.
So we can begin with the first CCP. It is the step of receiving raw materials and cleaning. So for this step, the hazard is chemical, and more precisely, it's the pesticides rate. The critical limits, we don't have a specific number, but we know that it exists a maximum pesticide limit rate, and we have to be under this limit. So for the monitoring, with the question of what it is the maximum pesticide limit rate respect, and for that we can check sheet coupon recept, and for the frequency it's before each reception, and it be realized by the different operators. So for this first CCP, we found the corrective actions. For the process, it simply look for causes and fix them. And for the product, we can check the pesticide rates And if it's higher than the limits, we can wash and clean and realize after a chemical analysis. And if it's not yet good, we have to destroy the product if it's not good. So we can talk now about the second CCP, which is seaming. The hazard is only microbiological. For the critical limits, there is a visual control. The cover must not be damaged. There is also a depletion control because we have to be higher than 0.3 bar. And to finish, the engagement is between 0.5 and 1 centimeter. For the monitoring, it's a visual control and a depression control. For that, we have 3 steps. The first one is a vacuum meter. After, we can use a rule, and to finish, we can look and touch the cap. And these operations have to be realized before the start of creeping, and it can be by seaming operators.
So for the corrective action for the CCP2, for the process, we can look for causes and fix them. And for the product, we can divide it in 3 cases. So first, if the bottle is not empty of air, if we saw that by a visual control, we can restart the vacuum process. Case 2, if the vacuum meter indicates no empty of air, we can also restart the vacuum process. And case 3, if after the restart of vacuum process is not empty of air again, we are going to process of product destruction. Then we are going to make the CCP3. Next slide, please. So for the pasteurization, the hazards are microbiological. For example, Escherichia coli, so insufficient heat treatment is the causes. So for the critical limits, we need to be above 90 degrees Celsius degrees for a time above 60 minutes. So the monitoring, we can have the temperature of etching first, so above 90 degrees, and then the time of etching, so above 60 minutes. So for the temperature, it would be thermometer. Frequency, continuous recording with only visual check and record with visual daily check of MEG thermometer, and who it will be the pasteurized operator. For the time of etching, we are going to use a timer for adjust the time for the temperature couple according to the pasteurization program. For the frequency, we are going to make it daily at the beginning of each production. And so it will be for the autoclavist operator or maybe sometimes the quality manager. Next slide, please. Thanks. And for the corrective action for DCCP, so as always for the process, we can look for causes and fix them. And for the product, we can also have 3 cases. So first, if the temperature is above 90 degrees but less than 60 minutes, so it's a lack of time. We are going to process about microbiological analysis. So for example, if the result is inferior to x66 cells per gram, we are going to process of a decrease of the date of consumption. But if it's above, we are going to process to the product destruction. We cannot accept the product. In the second case, if the temperature is too bad and the time respect, we are going to make microbiological analysis also. And same case, if there is too much microorganism in the program, we are going to destruct the product. But if it's acceptable, we are going to decrease the date of consumption. And in this case, if the time and the temperature are not respected, we are going to destroy the product. So thank you for your attention. Thank you for watching, and we can ask a question.
Thank you for the presentation. Lots of information.
Thank you very much.
Yeah. I have one question. Since you say that your product is a low pH, how do you make sure that your product is the pH of your product is lower than 4.6 or 4.5? Which step?
So like we will do before simming, like mixing everything and before putting in can.
Yeah, I agree. You should use that step for the mixing step. You should measure the pH of the product. And let's for how many people in your group? How many students in your group?
I'm not sure.
By the way, so I'm quite sure that not every student present. So if anyone who did not present, please give me the answer. I'm going to ask another question.
Okay.
So if you measure the pH at the mixing step, do you think is it critical to control the safety of your product? Is the mixing step important to control the safety of the product? Student from group A, I have the name of them, like, okay, can you know, you present. Pu Pa, are you here?
I'm sorry, but I think that Pupa is at the hospital because he has problem. He told me by message, so he's not here today.
Okay. For Father Manong, okay, you here? And you already present. Oh, Gasti, you already present. For Hugo and Alice. Alice, do you present? Did you present yet?
Yes, yes, she did.
Okay. So if everybody has already present, so anyone can give me the answer. The question is the mixing step important to control the safety of the tom yum soup? Because you have to measure the pH. And the pH reflect, and the pH is reflect to the temperature of this pasteurization, right?
Yeah, I think it is.
If you think that the mixing step is important and it can control the safety, should it be the CCP?
If it's in this case, so I think it is.
Yeah.
There is a pasteurization after, so it's not a CCP, no?
Like we have to check that is it the pH is a low pH food or not. So if it's like it is a low pH food, we can just use pasteurization and it is good for all. Like this.
Yeah. If you check the pH and the pH is high, what you're gonna do if you check the pH and pH is higher than 4.6?
We can use the higher temperature. Like we can move to some kind of sterilization.
Yeah, that's the corrective action. It's plan and one plan that you can do that. You can use the sterilization, or you can add some organic acid. For example, you can add citric acid to lower the pH, to reduce the pH the lower than 4.6, and you can use the pasteurization. See, if you see that, you will see that if this mixing step is the CCP, you have to monitor, you have to verify, and you should have the corrective action.
Okay.
And Valerie, do you what do you think about this?
I not the same question than you. I think considering the HCCP method and the HCCP plan is not important if mixing is not a CCP, but it's very, very, very important that in the plan, in the HCCP plan, there is the control of the pH. So I think I agree with you. I think mixing can be considered as a CCP with control pH and have corrective action, like you said, add citric acid or adjust the time and temperature pasteurization into sterilization. And I have another question for the group A for the CCP2, which is simming, because the critical limits you present are not made for cans. These critical limits are made for jars. I think it's a thing we already speak about. So can you propose another control and another critical limits for the CCP simming? Because this is for jars and not for cans.
Visual control and cut the can for measure the hook for measure the hook of the can. More than 1 millimeter.
It's okay for me. Oh, no, so I have another question about the corrective action of pasteurization, because you propose that if the rate of cells are under or extra XXXX cells per gram, you decrease the date of consumption. But here we have a long shelf life product. So it means that if you pass the date of consumption, you can eat it, but maybe he might, yes, he might the quality of texture or taste might decrease with the time. So it's not a question of it's not a sanitary aspects. It's just taste or texture or etc. So decrease the date of consumption is not really I don't know, allow, I think, because we changed the kind of date of consumption. Is the product became a short shelf life, I think, and that's so there is a lot of consequences, because if it's a short shelf life, you have to store it on the fridge. No?
It's maybe the texture. Yeah.
Because if your pasteurization is not enough, you can guarantee to your consumer to have a long shelf life. So it became a short shelf life with condition of storage. So I think there is a problem here. And that's all for me.
Or if we like do the repasteurize or something like that. I think maybe it could help.
Okay, thank you, Group A. Should we move to Group B?
Hello, so we are going to present our project. So we are going to present our project and our product. So at first, we're going to make a presentation of product. Next, we will do. Tu peux remettre là? Ok, merci. Next, we will do a list of the potential hazard in our process, the plan critical limit, the board for listing hazard, and the list of risk of each stage. Then we will see how CCP are determined. And we will also see a critical limit and at last corrective action. So what is our project? Our project is making an HACCP plan strategy of a food product. And our product is canned green curry with tuna.
I'm going to present our product, canned green tuna with curry. Sorry, I have a little problem for my computer. Excuse me. We have a look at the product presentation. First, we will see the description of the product. Then we'll have a look at food safety characteristics. I'm also going to present the shelf life and the ingredient. You will see also packaging and labeling instruction. At last, we'll see storage and distribution. So, what is a green tuna with curry? Basically, it's a soup. It's very sweet because it contains coconut milk. And it's spicy. Why? Because we have a red chili. How do we eat this soup? Actually, we eat this soup with rice or bread. Green tuna curry is very healthy. Why? Because it contains very nutritious herb. For example, basil is good for metabolism. Another point, it's very high in protein, so it's very healthy. Let's move on the shelf life. It's 30 months for the green tuna with curry. Next, the instruction for storage. We should store in a cool, dry place, and once opened, we have to store in fridge below 5 degrees and use waiting 3 days. So, what are the ingredients? The first ingredient is tuna. We have also green curry paste and coconut milk. And we have turkey berry, kaffir lime leaves, and at last we have chili. So, Chloe, can you move on the next slide?
I'm going to present a diagram of green curry with tuna. Basically, at the top in green, you can see the ingredients. Then in blue, you can see process the frying with temperature to 100 degrees. Also mixing. Next, putting in jar. We putting in cans. We have to 185 grams.
Excuse me, I have a little problem with Wi-Fi.
Okay, so list of the potential hazards in our processes. First is biological hazards. That's any microbial contamination, bacteria, or anything. Yeah, yeast, mold, anything. So in example, it's botulism, histamine poisoning. This one can find in many fishes, and staphylococcus enterotoxin poisoning. These two are the most famous in canned fish hazard. Next one is chemical hazard. That could be any chemical that you use in process that it contaminate into your product. And the third one is physical hazard, like some metal contaminated onto your product. And the last one is allergic hazard. Some people, they say like 1% in the USA of people are allergic to tuna. Yeah, next.
So for the board for listing hazard, we use 5M, raw material, labor, method, environment, equipment. And we use three kinds of hazard: biological, chemical, and physical.
Okay, for the list of each step, start from step 0, receiving raw materials. We separate to 3 lists that have physical, chemical, and biological. For the physical, we have from our product is the ocean plastic piece in fish and the fish bone. From the chemical, like a pesticides, and biological is pathogen. Next step is firing step. Firing step also have 3 lists that is physical, biological, and chemical. For the physical, we beware the growth piece that can get in the product while firing. Next is biological. We concerned about the temperature that we setting, and the chemical to cleaning and different residue. Next piece. Next step is the step that we putting in the cans. For this step, we have 2 of biological and 1 of chemical and physical. For biological, we concerned about the dirty spoon and the temperature or duration. Chemical is same as the step before, and physical we beware dust, metal, and the metal shafts. Next step is the can seaming. Can seaming is have risk in biological, it's about long time and bad in can seam. For the chemical, is the maintenance machine product. And the physical is the metal shaft. Next one, please. For the step 5 and 6 is the inkjet marking and sterilization. These 2 steps have a biological risk. That is the pathogen if duration step is too long, and the pathogen if temperature or duration are not enough. Next, please.
So, how CCP are determined? Critical control point is a step at which control can be applied and is essential to prevent or eliminate food safety hazard or reduce it to an acceptable level. The correct determination of CCPs is vital to ensure that there is effective management of food safety, and the number of these CCPs in the process will depend on the complexity of the product and the process itself. So CCP should be determined through a tree of decision, which you have on the screen. So there are many points that we can ask if there is yes or no, and if it is yes or no a CCP. So the first question is, do control preventive measure exist? And through this question, we're gonna see if each step is a CCP or not. So for that, we're gonna see some of the example of our products. So the first one is, can I have the next slide, please? Thank you. So in our process, one of the CCP that we found is the example of sterilization. So for that, we ask ourselves, do preventive measures exist? So the answer is yes. So we can go through the next question. The next question is the step specifically designed to eliminate or reduce the likely occurrence of hazard? And obviously the sterilization, the aim of this step is to eliminate the most hazard we can have. So if the answer to this question is yes, so it's a CCP. That's the easiest example. And after that, we have some more complex. So as another example, we have the step 4, which is can simming, that we have to go through more questions, but at the end, we have it's a CCP2, because when we ask ourselves the question, could contamination with identified hazard occur in excess of acceptable level, the answer is yes, and we can eliminate this hazard, so it's a CCP.
I'm going to talk to you about critical limits. So for our product, we have 2 CCP, can simming and sterilization. Both have critical limits. So what's the issue of the main issue of critical limits? It's to prevent microbiological hazards from contamination or multiplication. So before starting can simming, we check few points to make sure the machine is correctly set, and if not, we have to do corrective action. Here, as you can see, we have a critical limit for can simming. So first, we have visual control. We pay attention on the can. We know we doesn't want a default for heat. We also check the airtight. We want a complete airtight and an overlap greater than 0.8 millimeters. And at last, we want a time between the first seal can until sterilization lower than 1 hour.
Let's focus now corrective action for can simming. First case, if the visual control is no conform. Next case, the visual control okay, but airtight no conform. Also case if the visual control and the airtight okay,
but overlap non-conform. We have to reset the machine. At last, the can simming is too long. We have to increase time or temperature.
So there we have the critical limit for sterilization. So basically, we want to set the temperature at 110 degrees for 2 hours and a F value under prime.
Let's focus on corrective action for sterilization. First case, if F value higher than 3 minutes, so temperature lower than 110 degrees, either time lower to hours or 2. We have to do reinforced stability test at 32 and 55 degrees be an independent laboratory. If analysis is confirmed, the product is accepted. Otherwise, it is not conform product destruction. Next, if value lower than 3 minutes, so F value between 2.5 and 3 minutes, we have to do same corrective action as for case 1. So F value lower than 2.5 minutes, the product should be destroyed. At last, if F value and the time or temperature is conform, but stability test is poor. Also, the product should be destroyed. In all 3 cases, you have to find out why it didn't work. So this project requires patience, and we have to be meticulous. So thanks for listening.
Thank you for your presentation.
Thank you. Any comments, Jitsuri?
I have one question about seaming. Could you give me some the reason?
No, just a remark plus than a question. That it's you have to be careful, but because sometimes with critical limits, you said several times under value instead of above or higher value. So sometimes it's correct on your slide, but it's not correct when you say it. But it's just that, because after that, I don't have any question.
Jitsuri, any comments or any questions?
If the seaming is the seaming time take too long, and you say that the corrective action is increased temperature and time, and how will you determine how long of the time and how long is the temperature in case 4? Could you give me more information on this? Case 4, too long operation, and you say corrective action is to increase time or temperature, and what temperature and what time and how How do we know? How do you determine?
It's 80 minutes.
Pardon, what could you describe it? Could you please say again? I missed some point.
Increase the time of temperature of sterilization.
Yeah, I understand that you will increase the temperature of the sterilization and time, and what degrees that you're going to increase it, and how do you know?
It's a very hard question.
Because
perhaps we can fix I don't know if it's fixed, but some other F value, because perhaps time is temperature is not important to be increased, but time enough to reach another F value, perhaps instead of 3 minutes, perhaps 4 or 5 or 10 minutes, I don't know.
yeah, so in this case, can you use the same temperature and time of the sterilization, but you monitor after you monitor the quality after the storage? Can we do like that?
Yes.
Thank you.
Any other comments? No?
No.
So what we are going to do now, I'm sorry, I'm going to share my screen. Okay, in the chat box, you should have a link. This link, we will ask you all together to fill this questionnaire. You see there is a link. You have it in the chat box. It's a little assessment. If you could do that all together, we are going to do that all together. We will give you 1 minute and 30 seconds for each question. We only have 5 questions, and after that, we can see we can share the screen. Okay. So you all have the link?
No, can you send it again, because my connection lost, so I don't have the previous messages.
Okay. You got it now?
Yeah, it's okay, thank you.
Okay. So 1 second.
Soit tu cliques dessus, soit
Ok.
sur le lien qui est dans la conversation.
Tu peux l'enlever?
Yes.
Là, vous avez que 1 minute 30, donc il faut se bouger. Vous pouvez le faire par téléphone.
Jean-Christophe, do I have to do?
Yeah, you can do it if you want as well. Huh? You can do it as well.
No,
I can do
thank
it as
you.
well. Yeah, you're right. You can do it on your mobile if you want, you know.
Okay.
Yes.
Who is STA? Oh, okay.
Non?
No,
C'est
just
toi et après t'attends.
yeah. You just wait. Everybody will. Putain, mais c'est à réfléchir un peu. Ok. C'est bon?
Yes.
Okay. Now, question 2.
Different. Nice. Fruitful. Funny. Expectation. Original. Sharing. Enjoyable.
T'as vu quelqu'un il doit raconter si c'était on avait écrit mais. Okay, let's move to next question. Thank you. Next one. So we can hear that. Yeah, it's interesting. Next question.
Be good. Voilà. Basic.
Okay, 20 seconds left.
So locked.
Okay, next question.
Yeah.
Next question.
Last question.
And the last one. Jitsuri? Jitsuri, can you hear me?
Yeah, I can hear you.
Okay, do you want to make any other comments?
It's oh, I think it's pretty late now, and today is the last day the last day of the activity. I appreciate your cooperation and thank you for your chance. Thank you, Jean-Christophe. Thank you, Valerie, and thank you all students for coming and learning and share experience together. Thank you very much.
Yeah, thank you, Jitsuri. We know that everything for the students, we want to thank everyone. Thank you very much, Jitsuri, for your cooperation. We know that everything was not perfect. We tried to do our best, and we had some great lectures, and the final presentations were better than we expected because we were a bit worried. So, but we know everything was not perfect. We will try to do better next time, and it's new for everyone, so we try to invent things. So sometimes it works, sometimes it doesn't work properly. We would have, in fact, we would have liked maybe more cooperation, more interaction between the students. So that didn't work properly, but at the end they managed to make a presentation all together, and that's the positive side. And so we hope that you learned a lot, and we wish you all the best.